Welcome everybody to Mizzy Math. Today we're going to be talking about properties of operations. So the word operations we know as being the difference between addition, subtraction, multiplication, and division. And we know the answers to these are called sums, differences, products, and quotients. Well, technically today we're really only going to be talking about two of these, which would be addition and multiplication. And what's really nice about these two operations is that they have some properties that kind of go together. You might be thinking, well, what does a property mean? Well, even when you talk about anything in science, properties deal with the characteristics, what we can do, and these specific properties are kind of like rules and guidelines that we go by all the time. What's also great about these properties is that you already know them, but you don't even know that you know them. The first one that we're going to talk about is the commutative property. And I'm going to spell that out for you only because it sounds like a different word, and we want to make sure that we're talking about the same word here. It's not commutative, it's not commutatives, it's commutative. Even though it doesn't look like it, that's the correct pronunciation of the word. And what this is all about is way back in first and second grade, your teacher asked you, well, what do you think 1 plus 2 is? I've got 1 apple and my friend has 2 apples. How many do we have in all? We all raised our hand. We said 3. Then we went back to our table, we opened up a workbook, and we did a few more problems just like this with very, very small numbers. And maybe one problem had this exact number sentence listed, and another problem may have looked like this. And some of you really intelligent, lovely little first graders said, well, if 1 plus 2 equals 3, I know that if I have 2 apples and my friend has another apple, that is also 3. So the fantastic thing about this is that even at an early age, we realize that addition can be done both ways. It does not matter the order of the numbers, that addition is fantastic in that way. So this is called the commutative property of addition. Algebraically, I'm going to write the equivalent on this side here. And when I'm talking algebraically, I'm saying that I'm going to use variables in place of the numbers that I have here, because you very well know that it just doesn't work for 1 plus 2 equals 3 and 2 plus 1 equals 3. It works for a multitude, an infinity amount of numbers. So what we're going to do is we're going to use variables, which are letters or symbols that mean different values of numbers. So I'm going to use x and y. X and y is something that I use on a daily basis only because I teach an array of mathematics, and those are very common variables to use. So here, what I'm going to do is I'm going to say, okay, well, x plus y is the same as y plus x. So in this case, this is the algebraic version of the commutative property of addition. So now let's speed up to about 3rd and 4th grade when you were learning all of those multiplication tables. You took your timed tests. You worked with flashcards, you did everything to make sure that you knew how to do your multiplication tables by the time you got into 4th and 5th grade. And sometimes, I'm sure there were times where you looked at the problem 6 times 7, and you knew that that was 42. Well, for some reason, you just couldn't understand that 7 times 6 was also 42. There could have just been a block in your brain. Now you have it, and that's fantastic. However, When we put those connections together, we realize, wow, it also doesn't matter for multiplication either. We can set aside the same numbers in different orders and end up with the same exact product. So in this case, this is the commutative property of multiplication. So now let's write that in an algebraic way. Let's take two different variables. I'll take A and B. Now in this rate, you've got to understand that the multiplication symbol as our x is slowly going away. That's why I put that dot there. That dot is not a decimal. When we start getting into decimals, this multiplication symbol is going to completely vanish, and that's what's going to happen right now. We're going to use A and B. A times B is the same as B times A. We simply switched around the variables. Now remember, I chose A and B, X and Y. All these variables mean something different. We can interchange these letters with any number that you can even think of, and it will work every single time. If A in this case is 2 and B is 5, well, of course, over here, B has to be 5 and A has to be 2 to satisfy the property. So now we're moving on to another property, but prior to moving on to this other property, let's kind of review these order of operations. PEMDAS, please excuse my dear Aunt Sally. Now, whether you like it or not, this is actually the old school way of doing order of operations. There's brand new ways that kind of just spell out things. You guys, this is technically just a mnemonic device to help you understand how to do order of operations. We're not going to go through the whole thing right now. We are primarily going to focus on the first letter, which is P. We know that this P stands for the parentheses. So we're just going to use that bit of information, and we're going to move on to our next property, which is the associative property. Now, the associative property takes parentheses kind of to a whole nother level, but you will absolutely understand why we have to take this property into consideration, because it does look a little bit weird at first. Now, PEMDAS says, order of operations says that I need to complete all of my operations within the parentheses first. That is a misconception that is usually overlooked, and we want to make sure that we nip that right in the bud. Now, this associative property is a little bit different in that way, in that we're just going to be dealing with addition. We're just going to be dealing with multiplication 2 separate times. Let me show you an example problem. I will do the quantity of 5 plus 3, easy numbers to work with to start out with, plus 7. Let's work this expression out bit by bit. PEMDAS says we got to work in parentheses first. 5 plus 3 is 8. Let's continue with our plus 7. We know 8 plus 7 is 15. Now, this property tells us, great, when it comes to addition, and there's addition throughout the entire problem, I can move those parentheses with ease. Instead of putting those parentheses here to encompass the 5 and the 3, I'm going to move it over to encompass the 3 and the 7. Let's watch it here. 5 plus the quantity 3 plus 7. Let's see if we get the same sum of 15. Order of operations says, let's do parentheses first. 3 plus 7 is 10. Let's bring down our plus 5. Well, we know that 5 plus 10 is 15. Did it work? Absolutely. When it comes to the algebraic version of this, let's pick I like these 3 variables, A, B, and C. They're the first 3 letters of the fantastic alphabet. Let's look at this here. We know that the quantity A plus B plus C would be the same as if we move those parentheses to these two variables, A plus the quantity B plus C. Now let's move on a little bit to the associative property of multiplication. Bring this down a little bit. Same idea. Let's start with some really easy numbers. Let's do, in the parentheses, 3 times 4 times 6. Let's see what this equals here. 3 times 4 is 12. 12 times 6 is, well, I know that 12 times 3 is 36. And if we double 36, we're going to get 72. Let's see if it works the same way here. Let's move our parentheses. 3 times the quantity, 4 times 6. Let's do parentheses first. 4 times 6 is 24 times 3. 3 times 24 is, in fact, 72. And you can always do scratch work on the sides of the paper if you don't know these facts off the top of your head. Don't ever be afraid to do scratch work on the side. So now that we've got the same products being 72, let's write this in an algebraic way. I'll use A, B, and C again. The quantity AB times C is the same as A times the quantity BC. Last but not least, we have one more property to work with. However, this property looks different when it comes to addition in comparison to multiplication. This property is called the identity property. And it's kind of exactly what it sounds like. When we think of the word identity, we kind of look at ourselves in a personal way. If we know ourselves really well, we're said to, have a good identity about ourselves. So if we think about it that way, that'll help us remember what the property is actually like. So in first and second grade, again, let's think about addition. You guys knew at a very, very young age that 0 was a really important number. 0 is a placeholder, and 0 is the absence of numbers. So we're not adding, subtracting, we're not doing anything to anything when we deal with 0 most of the time. Now, we know some rules. Let's take a number 12. If we add 0 to 12, what will we end up with? Exactly where we started. That's the identity property of addition. Pretty simple. Now, let's take a look at the identity property of multiplication, and then we're going to talk about both of these algebraically. The identity property of multiplication, well, we've got to think about how do we get back to where we started. Let's take another number, 15. What could we multiply 15 by to get 15 again? Of course, it's 1. 15 times 1 equals 15. So both of these started out at a number. We added a 0 to obtain the same number that we started out with, or we multiply that number by 1 to obtain the same number we started with. Let's look at these a little bit algebraically. I'll use A as my variable for the addition and B for the multiplication. For addition here, when we talk about it algebraically, it's going to be A plus 0 equals A. Pretty easy. Algebraically here, let's use B. B times 1 equals B. That is it for today. I hope you had a fantastic time learning about properties and all the fantastic math skills that you pretty much already learned and now have a brand new name to call them by. So enjoy yourself.